Okay, good morning. Welcome to
SuperMath number 6.
SuperMath number 6. So at the end of our first chapter in our geometry book, they have a little aside about the golden rectangle, and it says this: a golden rectangle is a rectangle that can be divided into a square and another rectangle, such that the ratio between the dimensions of the new rectangle equals that of the original rectangle. Okay. Well, that's a little bit of a complicated description, right?
Yeah.
So let's see if we can understand that. So we have a rectangle, and we don't know anything about this rectangle, other than we're going to be able to divide it. Okay?
Yeah.
We're going to divide it into a square. This is going to be the square here. And a rectangle whose dimensions are in the same ratio as the original one. So in other words, this rectangle is just a smaller version of the big one. Okay?
Yeah.
And we have to understand how to do that. So we have...
So that would mean you can do it over and over again.
that's right, you could do it over and over again in here, in this one for example. Well, let's do that at the end actually. Okay? So they do something actually pretty neat. They call the long side of the original rectangle x, goes from there to there, and they call this 1 for the square. Okay? We don't know what it is, so we'll just call it 1. So the big rectangle has dimensions 1 and x. Okay, but we made a square here, so can you label the other things that are going to be 1 here? Oh, you have a pen. Okay.
So this is 1.
Okay.
Means that's 1 and that's 1.
Alright.
And this.
And that's 1. Okay, great.
So this here is 1 minus, actually it's x minus 1. That's this distance.
Okay.
Because the original distance is x, and you're subtracting away 1.
Alright, so and because this is positive, what did we just learn about x?
X is bigger than 1.
X is bigger than 1. Okay, and it said the ratio in this rectangle of the sides is the same as the ratio of this rectangle of the sides. So in the big rectangle, the ratio of the sides is x to 1, long side to short side, and that has to equal the ratio here. What is the ratio in the smaller rectangle?
It's x minus, well, the short side, it's 1 to x minus 1.
1 over x minus 1. Okay. How can we solve for what x is here?
Well, we could, well, it says x is 1 over x minus 1.
Right.
So, we could multiply by x minus 1.
Okay.
On both sides.
So that's going to tell us that x times x minus 1 all over 1
equals 1.
Equals 1. Or in other words, x squared minus x, because the divided by 1 doesn't do anything.
Yeah.
X squared minus x equals 1.
So, something squared minus the same something. Well, this says x squared equals 1 plus x.
That's true, it does say x squared equals x plus 1 or 1 plus x, but does that help us?
Not really.
Huh?
So what squared is something plus 1? Or what squared minus the same something is 1?
Right. How do we solve an equation like that?
Well, we could try some values.
You could. You won't stumble upon the value that works here. That's for sure.
It doesn't look like it's going to be an integer.
It's not an integer.
How would we solve an equation like this?
Good question.
Well, we could take the square root of everything.
You could.
Though that won't do much. What can we do here? This sort of is a quadratic.
Is it?
Except that it doesn't have the third bit.
What's the third bit?
It would be an integer. It would be plus 0, I guess. X squared.
I'm not sure what you're trying to do.
Well, the quadratics usually have 3 parts. You have the x squared,
Alright,
and then minus something times x,
okay.
and then minus whatever is the integer bit.
Okay.
But we don't have that.
So quadratics are just what, normally?
Oh wait, we can make it like that, because we could say it's x squared minus x minus 1 equals 0.
Okay.
So now, x squared minus x minus 1 is 0. What is x going to equal?
Good question.
Well, we have the x.
Yeah, this turns out this one's not going to factor.
Alright.
So what do you do when quadratics can't factor?
You use the quadratic formula. And wait, it's minus b times the square. Wait. It's minus b plus or minus the square root. It's b squared minus 4ac all over 2a.
Okay. So this is coming back to you now. Alright.
So, well, what's our b?
Okay. What is B? In fact, let's write them all down. What's A, what's B, what's C?
Well, it's the coefficients in front of these.
Yeah.
So a is 1, b is minus 1, and c is minus 1.
Okay.
So let's plug these in. So we get 1 plus or minus the square root of, actually it's I. Wait, no, minus,
What?
wait a minute, minus 1 squared is 1.
Okay.
Oops.
Phew.
Minus 4ac, which is plus 4
Okay.
over 2. So this is, well,
You write it down here.
1 plus or minus the square root of 5 over 2.
Alright. So we get x is 1 plus or minus the square root of 5 over 2. That means x might be able to take two values here, but there is a problem if we think about what these values are.
Well, the square root of 5 is bigger than 1.
Yep.
So 1 minus the square root of 5 is negative.
Yeah.
And we said x was bigger than 1.
We said x was bigger than 1.
So it's just
1 plus the square root of 5 over 2 is the special value for this rectangle. And that's about 1.618 if you put it in a calculator. So 1.618 and 1 gives you a golden rectangle. Alright?